Hello, everyone, and welcome back. So we're moving on to the next part of Chapter 6, no longer differentiating new rules and learning new tricks there to add to our toolkit. But now we're talking about Section 6.4, which is going to talk about average value. Now, we don't use the word average. We're mathematicians, so we're going to dive into the stats world of math and talking about the mean value. So mean, again, think about is just average. And any of you in AP stats right now, I'm sure you know what mean means. So what's the average value of functions? What's that look like? And we're building into a very big theorem that you're going to see in the next video or two. Forget. So let's say we have a velocity function given by the function negative x to the fourth plus 7x third minus 14x squared plus 8x. And visually, if you graph this, and we're going to look at this on the domain of 0 to 4. Where at 0, there's a root. I'm going to scale by 2s here. 1, 2, 3, 4. At 1, there's a root. At 2, there's a root. And at 4, there's a root. And it's going to look something like this. Through. Like so. This is a sketch of v of t, where we're talking about the velocity. We'll just do miles per hour and time here in hours. Okay. So this tracks someone's velocity. And remember understanding a graph. If velocity is 0, that means that you're standing still. A little recall way back when we learned this and the physics part of this, standing still. So when we're here, that means that you're speeding up because you're going away from standing still and you're speeding up, getting to a faster and faster velocity until you start to slow down and get back to a still position, in which then you speed up, but now you're going backwards. You're speeding up, going backwards, and then you start to slow down, returning to a still position, and then you speed up again, this time going in the forward direction. And you're accelerating, going faster and faster and faster, where you reach a very high velocity, and then you start to slow down because, I don't know, there's red lights along the way, so you have to stop. Now, the question is what if we wanted to find your average velocity along this trip? Average velocity along this trip, or from time 0 to 4. Okay. So to find average velocity, again, think about interchange blocks, the word like mean now. Now I know median is also a good word for average, but for math, we're using mean for this theorem that we're building. So average velocity can be thought of as your change in displacement over your change in time. More or less, what's your final position and how long did it take you to get there? And we can calculate your average velocity over that trip. Now, how do we find your total displacement here? Where we started at 0, how would we find your displacement on this velocity graph? In other words, like how many miles did we travel? So you might say, so this is in miles, and this will be in hours, which will net us miles per hour. How do we find how far we traveled? Or not necessarily how far we traveled, but our displacement. Remember, if you want to find an accumulation or amount of anything, we have to use integrals here. Or in this case, to get miles, we have to take the integral of this function. So to find displacement, it's going to be the integral of v of t dt. And we're going to do it from 0 to 4 here, because we're talking about displacement, which allows for going backwards. If we're talking about speed, speed is the absolute value of velocity, then you would have to account for that being positive, in which we'd have to break this integral up. But we don't have to here because displacement takes that into consideration. So it's to be 0 to 4 of v of t dt. And for purposes of saving time, I'm going to put this in a calculator. So we have math function integral, and we're going from 0 to 4 of our function, which is going to be negative x to the fourth plus 7x to the third minus 14x squared plus 8x with respect to x as time is changing. And what we'll get here is approximately 8.533 repeating. And remember, calculus, as we do the work, take it out 5 numbers, your final answer can be 3 numbers out. Good. So what this represents is in 0 to 4, our displacement is we're 8.533 miles away from the start, from our starting position. Okay. So that's going to be 8.5333, 1, 2, 3, 4, 5, over our change in time, which is 4, which will net that our average velocity here is approximately, divide that by 4, our average velocity is 2.133, and it looks like repeating from there, miles per hour. So along this trip, as we were speeding up, slowing down, speeding up, slowing down, speeding up even more, and slowing down even more back to 0, our average velocity along that trip can be found by 2.133 miles per hour. And where's that at on the graph? Well, the high point of this graph, what is the high point of this graph? Let me put this in a calculator so we can see this more accurately. So if I put in negative x to the fourth plus 7x to the third minus 14x squared plus 8x. And let's do zoom fit. Zoom 0 is what I hit. That's not what I want to see. Let's change my window here because let's go 0 to 4. I don't know how big. Let's try negative 10, see if that works. Actually don't know what it's going to be here. Good, good, and yes, as I remember looking at. Okay, so where's our average velocity on this graph? 2.133, where the high point, calculate a maximum. My left bound is 0. My right bound, I'll just put as 1.5. I guess is in between there. My max is occurring at 1.38. So this value right here is 1.38 roughly. And that max is occurring at 0.39. Well, notice 2.13 is above it, so it might be somewhere up here on my sketch. So this right here is my average velocity. And you can see that along this trip, how many times did I travel my average velocity? Well, 2 moments. And these 2 moments right here, I was traveling my average velocity. And we're building into this in the next video, and the idea is that will you always hit your average will you always, on a trip where you calculate you're keeping track of data, will you always hit your average? Or is it possible to skip over your average? Does average have to occur? And maybe you know the answer to that already based off this, but you can see that in this problem, find the average value of this function. It happened 2 times. So we'll build off that in the next video. All right. Hope that helps with this lesson, and you followed me through all that. All right. Bye-bye.